Hey, what's good? Hope you're doing well. Got a quick question for today, just based on like precipitate forming or not, and we're just trying to find out like what concentration of adding like a compound will cause separation, and then like what will precipitate first, like which ion will precipitate with the other first. So, my bad. So what's the first step? Well, I need to get my periodic table. Why did I close it? I literally had it open. 102 data sheet. Okay, so we want to find the concentration of S2 minus that'll cause precipitate to form. And what we want to do is kind of like write out each one. So we're looking at S2 minus. What the heck is this? We're looking at S2 minus, right? So S2 minus is an anion, so we're only going to be looking at the cations. So we're going to be looking at nickel and cadmium, I believe, so Cd. So this reaction, or like the solubility reaction, this will just be Ni, nickel sulfide, and it'll just be the the dissociation reaction. Bro, why can't I like write the right thing? S2 minus of this kind of compound that we're looking at, because nickel sulfide is what we're looking at, like that's what we want to, like that's what the precipitate will be, and we need to find out what the KSP is to find out how much how much sulfide ion we need in order for that like precipitate to be formed, if that kind of makes sense. Well, like I think it will. So KSP based on my data sheet is 1.7 times 10 to the negative 21. That's the KSP of nickel sulfide. And KSP, this is going to be equal to the concentration of nickel multiplied by the concentration of sulfide ion. I forgot to try, actually, it's fine. We're not including nickel sulfide because that's solid, and we only include aqueous species in our equilibrium constant equation or whatever, right? So what do we need to do now? We need to find out the sulfide concentration. So KSP over nickel concentration is going to be equal to sulfide concentration. Now we just got to solve that. So what's the KSP? 1.7 times 10 to the negative 21 over nickel concentration. We have that in the very first value. This is 1.0 times 10 to the negative 6 moles. And now we just gotta solve that. So once we plug that in, we should get a value of, where's my 1.7 times 10 to the negative 15 moles. So I'm not fully sure if that like kind of makes sense. So we're trying to find the concentration of sulfide ion that will lead to precipitate forming. So we need to find the KSP value of the solid that we're like trying to precipitate. And then from there, because we already know the concentration of nickel 2 plus ion, we could just solve for the sulfide ion concentration. And then from there, we'll be able to know how much sulfide is needed for the KSP value to kind of fulfill itself. Like, wait, I don't know. That I feel like that wording is really bad, but it's like the KSP, maybe I'm just missing something like information or like how to explain it, but it's like in my mind, what I'm thinking is like, KSP, that is like where the reaction needs to be at in order for the precipitate to be formed. So in this case, we're trying to find out how much, like what concentration of sulfide ion is needed in order for us to reach that like point in the reaction for the KSP to be like fulfilled, you know what I'm saying? So because we know the nickel ion concentration and we know the KSP value, we could solve for the sulfide ion concentration and then, find out what concentration of sulfide ion is needed to precipitate the nickel. if that makes sense. That's like what we're mainly doing. So yes, we could just move on to the next one. So the next is cadmium, but I might be like saying the completely wrong name, but we'll just write like the exact same reaction, CDS solid and for me this value is the KSP is equal to 1.4 times 10 to the negative 29. Now oh wait no, that's right. We defined sulfide ion. Now if we solve that in our calculator, get a value of 1.4 times 10 to the negative 23 moles per liter. So now just comparing these two values, wait, look, you want that to be thicker. Comparing these two values, right? We could see that it requires a much lower concentration of sulfide ion in order to precipitate. Like it takes much less sulfide ion to precipitate cadmium rather than nickel. So for the range of, like, we could call this like process of adding. So it's going to be high and it's going to be low. So like, you know, as we keep on adding it, then more will precipitate. So right here, this is, we'll call this 1.4 times 10 to the negative 23. So in this area, only CD cadmium 2 plus, or only, wait, no, not below. Wait, this is the wrong, okay, wait, let me just write the other range as well. Okay, so in this range, no precipitate. In this range, this will be only CD2 plus PPT, and then in this, both two plus, and if that kind of makes sense. So like, you know, as we keep on adding more and more what is it called, sulfide ion, like there'll be a specific range where only cadmium will form a precipitate, and then once we reach that threshold for nickel to precipitate, then both cadmium and nickel will also precipitate together. But in the range before the cadmium is able to precipitate, then there'll be no precipitate being formed, which is like this kind of region over here. So there'll be no precipitate here, only cadmium here, and then after that, both will do it. So yeah, that's honestly pretty much all for today. A pretty quick lesson, but I'm low-key still learning this stuff as well, and you know, I'm slowly going through the motions of this shit, bro. Like, oh my god, bro. School is like, bro. School is school, bro.